So last week when we started the Pythagorean theorem, we were using the two legs of the right triangle, and we were finding the hypotenuse. So today we're going to actually talk about how to find the leg. If you look at this triangle, and this is a good example to keep in your notes, we have a right triangle. Which side do we not know? So if you look here, this is the right triangle. Do we know the hypotenuse? Yeah, we know the hypotenuse. The hypotenuse is 7. So one of the legs is unknown. So we have to figure out this. We are still going to use this same formula to do that. Okay, what is that formula? A squared plus, what's the next part? B squared, good. Equals C squared, good. So we're still going to use this same formula. Which values are given? If I had this formula here, remember we talked last week, if you have to calculate the Pythagorean theorem, you're going to be given 2 of the 3 sides. Can I replace A, B, or C with the numbers that I've been given? C is given. What is C? 7. So I can take this here and I'm going to replace it with a 7. What else can I replace? Which one? Does it matter? No, it doesn't matter. Think about the commutative property. 2 plus 3 is the same as 3 plus 2. The order of the legs doesn't matter. They actually serve the same purpose, so you can actually substitute in whichever one you want. Let's just say I wanted to plug in for B. Do I have enough that I can calculate that right now?
Yeah.
Yes, I do. Let me stick over here. So if your classmate said, I think that A is 9, how could you prove that they're wrong without doing a single calculation? So take a look at the calculation that we have, A squared plus 6 squared equals 7 squared. They're saying that they think this is 9. How could you say you're wrong and I know why without doing a single calculation? What do you mean little? Okay, so the size of that leg doesn't look that long. How else? What other? You're right, but what technical part of the triangle do we know?
The hypotenuse is always bigger.
The hypotenuse is always the longest side. So no matter what happens, the leg has to be smaller than what? It has to be smaller than 7. So your friend would be wrong because if this is a leg and not the hypotenuse, it can't be 7 or bigger. It has to be smaller.
It has to be even smaller than 6.
Yeah, based on this. I mean, I didn't really scale out this triangle, but based on this image, probably. Okay, so if we have A squared plus 6 squared equals 7 squared, okay, we calculate A squared plus 36 equals 49. How would we solve for A? Think back to our first unit. How would I get A by itself? Subtract what? Subtract A.
36.
I can take 36 away from both sides. Remember, our goal here, and this is a connection to Unit 1, we want to isolate our variable. So anything that's happening to our variable, we're going to undo it. If I take 36 away, I am left with just A squared on this side. And what's on the other side? 13. So now A squared equals 13. How do I find just A? The square root. So I'm going to do the square root of what number?
13.
And what is it?
3.605.
You can estimate 3.6. Does that make sense?
I got it right though, didn't I?
You said that it had to be small. Yeah. Does this make sense? If one leg is 6 and the hypotenuse is 7, does it meet our criteria? Is it smaller than 7? Yeah. And if I did the calculation, 3.6 squared plus 6 squared would give me 7 squared. So our side length here, our leg, would be this. Now, what differences do we have? Is there much difference between finding a leg compared to finding the hypotenuse? No. What's the only thing in addition we have to do to find a leg as opposed to the hypotenuse? At this level here, I'm going to erase this. Okay. You're still going to set the formula up the same way. A lot of you are using this visual and you're showing A squared plus B squared equals C squared. You're showing the values and then you're doing the calculations here. Very helpful to continue to write this stuff in your notebook, even though you're using your calculator. It keeps it organized. What do you notice between this and what we would have said? Notice the difference. This is what we were working on last week. We had A and B. We squared them. We added them. We found C. The difference there, once we calculated, we were able to just find the square root. Over here, we actually need to solve the equation first, right? In order to get A by itself, I can't find the square root until A is alone. So that pulls back in some previous knowledge from Unit 1, which is why later this week, one of the days that I'm not here, you are going to practice solving equations, right, to get back into this mode. Does anyone have questions about finding a leg versus finding the hypotenuse? Okay. So this is the last thing that I want you to write down. This is a really great guide for, based on what you're given, what you're going to be finding. Okay, so if we have the formula a squared plus b squared equals c squared, if we are given two legs, we are finding the hypotenuse. So if we are given a and b, we're going to be finding c. So this was last week. So write these three examples down. Today, we talked about the next layer. If I was given one of the legs and the hypotenuse, I would be finding the other leg. Why do you think I added two of them? Like it says leg A, hypotenuse C, finding leg B. Leg B, hypotenuse C, finding leg A. Why do you think I did both?
Because that's what you're given.
Yeah, it's based on what I'm given, and the legs really don't matter. I don't want you to think that if you're given a leg, you have to know if it's A or B. Based on how the triangle is laid out, you can determine that. The only value that definitely has to be what it has to be would be the hypotenuse. So have these examples down. While you're working on an example, if you are ever unsure of how to perceive what you have been given, this is a great guide to look back to. Oh, I was given both legs, I'm finding the hypotenuse. I was given one leg, I'm going to find the other leg because I was given the hypotenuse. And you can always draw a little picture. Does anyone need more time to write?